There, new section, word problems. We get into examples immediately. So let's just write a learning goal right here. I will learn to model quadratic equations to solve problems. Okay, so let's do example one. First thing we need to do is understand how to model them. So first thing, for 3 consecutive integers, there's 3 integers. How do you model 3 consecutive integers? So you let a be one integer. If it's consecutive, the word consecutive means the next one is a plus 1, because one comes after the other. And then the third one is a plus 2. It's a third integer. We don't know what a is, but we know the next one is going to be 1 more, and the next one's going to be 2 more. Now, it says the square of the first plus the square of the second less the square of the third less. Okay, so we're going to model that. Oops. We're going to model that right now. The square of the first, that's a squared. This is the first integer. Plus, put a plus sign. The square of the second, that's the square of the second. Less, that's minus. The square of the third, that's a plus 2 squared, is, oops, why did it do that? Oh, that's my handwriting. Whoops. Great. Now is means equals 117. What is the sum of the 3 positive integers that satisfy these conditions? Now, first of all, you notice right here, immediately, that we only have one variable, and that's a. So we can solve that, but the question doesn't ask what a is, it asks what is the sum of 3 positive integers. So it's asking what's a, the first one, the sum of the first one, plus the second one, plus the third one. But first we need to find a to find this. We use this to find a. So what do? Well, we have to expand. We have to write this down. Oh. And we expand this. How do we expand this? Well, you can FOIL it, or you can just recognize that this is a perfect square. So that's equal to the square of the first plus 2 times a times 1 is 2a plus the square of the second. And that's how we got this. So we know that that came from there. This came from here. And of course, this is the same thing. Minus, keep the minus there. And keep this in brackets. The minus operates on all of this. So we have the square of the first, a squared, 2 times 2ab, which is 2 times a times 2, which is 4a, plus 2 squared, which is 4. Let's do that separately, okay? This becomes square of the first, a squared, plus square of the second, plus a times 2 times 2, which is 4a. And that's how we got this down here. Okay, write it all out. What did we do here? How do we get from here to here? This is just that. No changes there. This minus is operating on all 3. And that's what happened. We have this minus a squared minus 4a minus 4. And then we brought this 17 to this 117 to this side. That's how we got 117. Next step, collect like terms. A squared plus a squared is 2. A squared plus, minus, sorry, 2a squared minus a squared is just an a squared. That's where that came from. The next like term is 2a. 2a minus 4a is minus 2a. And then the next like term, we're done this, is negative 117 minus 4 minus 1, 2, 1, plus 1 equals minus 120. That's where we got that from. Okay, and now we have to find two numbers. How do we get that? Let's find. Whoops. How do we get that next step? Well, we have to find two numbers. Let's do it on the side. Find two numbers, product 120, and sum to minus 2. We have 1 and 120, 2 and 60. There's no way it's going to get minus 2. What about another obvious one, 12 and 10? 12 and 10, but they don't sum to minus 2, they sum to 22. What about minus 12 and 10? Minus 12 and 10 is, they add up to minus 2. And that's how we got a minus 12, a plus 10. Which means a, in order for this to be 0, a has to be 12. Or, in order for this to be 0, a has to be equal to minus 10. So we have two possible solutions, a equals 12 or a equals minus 10. Let's read the question. What is the sum of three positive integers? So that means, if that's one of the integers, it can't be, because it's positive. So a equals 12. So the sum is, so we substitute 12 in here, 12, 12, 12, and we solve. The sum is 39, and that's my answer. Example 2. A swimming pool, now we have to analyze. We have to draw a swimming pool that is 40 meters by 20 meters. We draw a little swimming pool. It's surrounded by 20 by 40. It's surrounded by a cement patio with uniform width. What's that mean? It means it's surrounded by a patio. The same width. This width is equal to this. That's what uniform means. The same. We don't know what the width is. So we'll just add x. The area of the patio, that's that length, times that length. What is this length anyway? Including the pool is to be 3 times the area of the pool. So whatever this area of the pool is, so right now we have this is. Let's look at what that means. Area of the pool equals 3 times, area of the patio is 3 times the area of the pool. What's the area of the pool? That's just 40 by 20. We got that from there. Length times width. Area of the patio, well, what's that? That's an x right here, an x right here, and 20. So 2x plus 20. What about this length? This length is, well, let's clear the pen markings a little bit. Whoops. This area right here, that's x. That's x. That's 40. So that's why we got 2 x's and a 40. And that's equal to 3 times 40 times 20, which is 2400. Now we have one variable and just one variable, x and x. So we can solve. What is the width of the patio? Do that. How do we expand? We FOIL. 2x, first term, inner terms, 20 times 2x. No, sorry. I forget. First term, outer terms. So the first term is 2 times 2x is 4x squared. 2x times 40 is 80x. 20 times 2 is 40x. And 20 times 40 is 800. With this minus 2400, we brought this over to the other side. And that's equal to 0. So now we can solve a quadratic equation that's equal to 0. Collect like terms. There's no x squares except 1. There's two values with x, and then these ones also are like terms. What's 80? Clear. It's 40x plus 180. Sorry, 80 plus 40 is 120. 2400 minus 2400 plus 800 is 1600, or negative 1600. And now we have to find two values that multiply to, well, actually, we can factor out the 4. We divide both sides by 4. So let's see how we got that. Whoops. We divide by 4. 0 divided by 4. 4 divided by 4 is, that gets crossed out. 120 divided by 4 is 30. And 1600 divided by 4 is 400. And now we have to find two numbers that multiply to 400 and add up to 30. Well, I already can see it. It's 40 and 10, but you can go through the motions. It's 1 times 400, 2 times 200. Can we get 30 from that? No. Can we get 30 from subtracting or adding these values? No, I can get 96, or I can get 104. Can I get 30? No. Again, can I get anywhere near 30? No. Can I get 30 with these two numbers? Yes. 40 minus 10 is 30. So I think I found my two numbers. So what do? I know that my numbers have to multiply, so one has to be negative, and the larger one is going to be positive when we add. So x plus 40, x minus 10. So what's my values? My two possibilities are x can be minus 40, or x can be 10. But can my width be negative? No, it cannot. So my value is 10. Okay, homework will be posted later, and